The topic of steering linkage covers many different parts that are all wrapped into one system, the steering system. That system involves everything from the base of the steering column all the way down to the steering gear and all the way out to the wheels where they turn. The steering linkage can have different configurations, and it's all dependent on what kind of suspension system the vehicle is equipped with. The best way to visualize this is probably to start off with something simple like a solid axle vehicle. With less moving parts in the suspension system, there's less need for moving pivoting parts in the steering system. Let's take a look at some of the components of the steering system on the 78 Jeep. Let's start at the left front wheel, where we have our upper ball joint and our lower ball joint, which are our upper and lower pivot points of the steering on the solid axle. Coming off of the spindle assembly is what's called the steering arm. This is normally going to be cast into the steering knuckle of a vehicle. It can also be bolted on there. But on the end of that is going to be the tie rod connection. The tie rod in this example connects directly between both sides of the steering. So if you look down that rod, you can see those two castle nuts on the end there. The one towards the right is the opposite end of the tie rod end on the passenger front wheel. Now this tie rod keeps the wheels turning together. In this case, this is a solid tie rod. It is one rigid component from one side of the vehicle to the other. With a solid axle, there's no need for any pivoting components in between the two wheels. On an independent suspension, there would need to be some sort of pivoting portion in the steering so there wouldn't be any binding happening. In this jam nut here, this rod is threaded inside, and this end, this outer tie rod end, has threads on it. So if this is loosened away from its mating surface against the tie rod, then the tie rod can spin and adjust this farther out or closer in. Now in order to turn the tie rod, we would need to loosen the jam nut on this side and on the passenger side at the same time in order to get this free enough to gain an adjustment. Tie rod ends adjust toe. So as the tie rod adjustment is either lengthened or shortened, it will either push this out further or pull it closer in. Following the tie rod from the driver's side to the passenger side, it comes in and connects to the steering arm on the passenger front steering knuckle. Now you'll notice the steering knuckle has an additional piece off the end of it. This is all cast into one assembly. Like I said, these can be bolted on or cast into the steering knuckle. Oftentimes they will be cast. We have castle nuts here, retained with cotter pins. And moving forward, this rod connecting here is going to be our drag link, or the relay rod. This drag link connects to the pitman arm. The pitman arm is the arm that swings with the movement of the steering as you turn the steering wheel left and right. The pitman arm is attached to the lower portion of the gearbox. In this case, it's a Saginaw style gearbox or a worm and sector shaft gearbox. And that the length of that pitman arm is specific to the design of the vehicle, just as the length of the steering arm from the pivot point to the tie rod end is specific to the vehicle, and the little additional distance we have from the pivot point to where the drag link connects to, or the relay rod. When the vehicle is turned all the way one direction, there may be adjustable stop points. This is what may be found on some adjustable steering stops. This is the mechanical piece that will limit the steering from turning any further once it makes contact with the axle housing. This prevents having tires rubbing on certain components and prevents other components from being damaged due to binding. This is the other end of the drag link, or the relay rod. This connects with the same type of ball stud, similar to a ball joint, but is under different types of load, not vehicle load, just steering loads. This is connected to the pitman arm. The pitman arm is then mounted you can see some of the splines in here, to the sector shaft of the worm and sector drive steering box or steering gear. The pitman arm is going to pivot left and right, and it's going to move this rod left and right. That motion is going to be transferred to the steering arm on the right front steering knuckle, and then the tie rod mounted to the same component will move left and right with the steering at the pitman arm. This is the basic concept of steering linkage from the steering gear on a solid axle vehicle. The suspension system becomes more complex with more moving pieces, especially on independent front suspension. Then the steering system will need to be able to accommodate the movement of the suspension without binding or what's called bump steer. The steering linkage are the mechanical components that connect the driver to the wheels. From the driver input to the steering wheel through the steering column will either then go straight into the steering gear or be accomplished through an intermediate shaft that links the steering column to the steering gear. The steering gear multiplies the force that the driver is putting in, and that's often done through gear reduction, and then with power steering, hydraulic pressure is added to the steering gear in order to assist the driver in steering one way versus the other. The gear reduction inside the steering gear has to do with the amount of times that the steering wheel is turned versus how much angular change there is at the wheels. The mechanical advantage through the steering gear, either through gear reduction, variable steering, and or through power steering as well, is then transferred to the output of the gear. Depending on the gear, it's either going to have a pitman arm or it's a rack and pinion style that is going to translate that motion directly into the tie rod. The tie rods are directly connected to the steering arm of the vehicle. There is usually going to be an inner and an outer tie rod end, especially on systems that have independent front suspension. Some of the suspension designs for twin I-beam and twin traction bars involve a pivot in the center of the axle itself. So the steering has to match the articulation of the suspension without binding. If, for example, we had suspension in the front that was twin I-beam and there's a pivot point in the center of the suspension. So the drive axles go out to the wheels and they're able to be independent of each other, but they pivot in the center. If we had a straight tie rod going from one end to the other end, as the suspension compresses and rebounds, the distance between each end is going to lengthen as it compresses and shorten as it rebounds. This would be a problem if there was a rigid tie rod connecting one wheel to the other. So on a system like this, where either side can move independently from each other, the steering linkage would need to be in line with the articulation movement of the suspension to avoid binding. So what would happen if there was an unequal length? Well, as the suspension compresses and the tie rod is fixed to this distance here, since the distance at the wheels would be getting wider and the tie rod end is fixed, the only thing that would be able to give would be the steering. So the tires, if that were the case, every time the suspension would compress and rebound, the tires would toe together or toe in and then toe out as the suspension were to compress and rebound, coming to rest in a straight ahead position. This design wouldn't be very feasible and doesn't work. So the steering has to be designed with the suspension system so the wheels point straight ahead in the driver's intended direction during compression, rebound, and independent articulation of the suspension. This is true regardless of the system and regardless of whether it's solid or independent front suspension. This example is a rack and pinion steering gear. The rack is referring to the long shaft in here with teeth on it, and the pinion is referring to this small drive gear here. We'll be talking about rack and pinion gears in an upcoming video, but this is essentially what's happening inside. This portion right here is called the rack, and this here is the pinion. So this is generally how they're configured. These ports are where power steering lines are connected, and that rack moves left and right as the pinion rotates clockwise or counterclockwise. The term pinion gear is a common reference in any type of gear train for the smallest gear in the gear train. So the pinion gear does not necessarily specify that it belongs in a rack and pinion steering gear. It just means it's the smaller of the two gears involved. And this is typically known as a rack and pinion gear. The action that occurs As the control arm changes its angle with the suspension on this McPherson strut suspension, as the compression and rebound occurs on that control arm, that angle needs to be matched with the tie rod end. Now, similar to the Jeep example, this end is very much just like on the Jeep, with the jam nut and a threaded insert. The difference being this is connecting an outer tie rod end to an inner tie rod end. The inner tie rod end pivots inside the steering rack boot. So in here, this is being sealed of dirt and debris. And the pivoting action occurs inside this joint right here. This joint can wear out, and this joint can wear out. Tie rod ends can wear, but they should always be able to pivot. This is normal movement. It would not be normal movement to have up and down movement or lateral side to side movement, but you should be able to twist because this is a ball stud component. Very similar to the construction of a ball joint, but it's under different loads, so it's designed differently. The rack and pinion gear assembly eliminate the need for many of the other linkage points that we get in other steering systems. The rack needs to be mounted firmly to the chassis of the vehicle, and that's done through mount bushings or mounting locations on the rack itself. Before rack and pinion steering was available, this type of steering for independent front suspensions was developed by using other linkage components in what's referred to as conventional steering linkage. It's also known by the name of parallelogram. Behold, my latest piece of art. Obviously, it's drawn to scale. Parallelogram steering, or conventional steering, uses a center link spanning across the center of the vehicle, and that center link is attached to inner tie rod ends, then an adjuster, then outer tie rod end. So the inner tie rod end, which is in orange, and the outer tie rod end, which is in green, are two separate pieces. In order to be adjustable, there's a threaded insert in between. Normally these are adjustable. Every vehicle is required to have at least a toe adjustment, which is going to be accomplished through the tie rod. Toe refers to the tires pointing inward or outward. Toe in is when the front of the tires point inward of each other, and toe out is when they point out with respect to each other or the center of the vehicle. This length, from this pivot point on the inner tie rod end to the center link, to the outer tie rod end at the steering arm, needs to be parallel with the control arm. If the control arm is longer or shorter than that, then the tire is going to steer as the suspension compresses or rebounds. So if there's a customer concern of hitting a bump or a dip and the steering wheel reacting to that bump or dip, then there's likely a bent component or an incorrect component installed on the vehicle. In this oversimplified view of parallelogram steering system, this is essentially what the rack and pinion is replacing. It's essentially the same type of idea where we have a moving component in the middle. On the rack and pinion assembly, the rack moves inside of the assembly left to right. So as it moves side to side, it moves the linkages side to side as well. Parallelogram steering was used with a conventional style gearbox. Before rack and pinions were developed for the majority of vehicles, the type of gearbox that was used is much like the one on the Jeep, a Saginaw or Worman sector gear. The steering linkage was designed with multiple links, and at every point where you have a pivoting link with respect to another, so in this location, down at the outers, those are all wear points. And with more moving components in the system, gives more opportunity for wear items and more opportunity for something to wear out to cause driver concern while driving, uneven tire wear, and even some safety concerns. The two things that I've added to the drawing on here represent the pitman arm and the idler arm. The pitman arm is one of these components. This has splines on the inside of it and engages to the steering gear. So the driver input into the steering gear is going to pivot the pitman arm back and forth that is connected to the steering linkage in order to move the steering left and right. Without the opposite end being supported, the steering system would not be effective. In order to support the other side, it doesn't necessarily require a separate steering gear, but it requires a pivoting bracket that's going to support and keep the steering linkage symmetrical and move with the pitman arm. This is done with an idler arm. An idler arm doesn't produce any force at all. It just transfers motion. And the radius, or the distance on which it pivots, needs to match the pitman arm. These only support the opposite end of the center link from the pitman arm. As I've illustrated, the idler arm is much less robust when compared to the pitman arm. These two are not created equal. So as the pitman arm pivots left and right, the idler arm is going to match the left and right movement, keeping that center link nice and level with the chassis. This pitman arm has a little bit of play in it, and I'm not sure you can tell, but the play is in this bushing right here. It is greasable. Proper lubrication intervals during servicing will prevent the premature wear of the idler arm, but they do wear about twice as fast as the pitman arm would. So with this having some play in it, would translate to delayed movement left and right compared to the pitman arm. So as that wears, this side is going to deflect through the wear of the bushings inside the idler arm and cause steering issues. Now, what kind of steering issues is that going to be? Well, it's going to vary from vehicle to vehicle. Same if we had wear on the tie rod ends, outers or inners on either side. Now, to throw it back to geometry, whenever that might have been for you, parallelogram refers to a geometric shape that is a quadrilateral, meaning it has 4 sides, and all sides are parallel with the exact opposite side. So a rectangle in the center is a parallelogram. The top and bottom are parallel to each other, and each side is parallel to each other. The parallelogram steering has to do with this geometric shape. We're maintaining parallel operation in both directions as we steer. This is illustrated by the 2 parallelograms on the left and the right of the rectangle. All these shapes are parallelograms. Imagine taking that rectangle and tilting it one way or the other, maintaining 2 parallel sides and 2 parallel sides. This is where the conventional steering linkage system gets the name parallelogram steering. So these terms can be used interchangeably. If any point of this steering system does not allow for parallel planes to be maintained, then something is worn, broken, or bent, and is going to result in adverse handling characteristics, tire wear, pops, rattles, and other noises. Next, let's take a look at the steering linkage. To steer from one side to the other, we have our steering arm coming off of our spindle, which connects the lower ball joint to the lower control arm and the upper control arm to the upper ball joint. We have our steering arm coming off the forward side of this. Now this is comprised of an outer tie rod end on both sides. Our tie rod adjuster connects to our inner tie rod end, which also has a linkage point here, a ball stud. That's connected to our idler arm, which runs parallel to the pitman arm, and it supports the geometry of the steering. And then connected to that is our center link. Our center link is adjustable with these jam nuts and these threaded ends. So if we loosen these jam nuts and we rotate this one way or the other, that's going to bring both sides in or out. And then we have connection to the pitman arm. Pitman arm is connected to our steering gear. Our steering gear is connected to our steering shaft, or our intermediate shaft. And that goes up to the steering column inside the vehicle. And then from the pitman arm, we connect to the left front inner tie rod end. And then our adjuster for our left side tie rod assembly. And then our outer tie rod end connects to our driver's side or left front steering arm. When servicing and separating outer tie rod ends and other steering components with tapered studs, the same principle applies as did with the ball joints. The tapered stud is going to fit into a tapered hole and will be very tight when the nut is removed. There are tools designed for separating these components, and depending or not whether the component is going to be reattached and reused for a disassembly-reassembly procedure, there are certain tools to use to prevent damage to the component and other tools that will damage the component if it's not going to be reused. You can see here with the pry bar that the pry bar is not able to loosen the component up. That stud is mounted in and is seating against the inside of that taper. The method that I like to use works really well in tight areas and with components like the dust shield right here, which can be easily bent, is to place the ball peen onto the component that needs to be shocked. We need to shock the area around the tapered stud. So we need to shock this steering arm, and by doing this, it gives me a little bit more of a reach and a little more clearance, so then I just have to strike the face of the other hammer, and that energy is then transferred through the hammerhead to the ball peen. And after it's been loosened, it lifts right out. But that seat has to be broken free. The other tools, like a pickle fork, is a fork with a wedge taper on it, and you wedge it in between the ball stud boot or the outer tie rod end boot, and you wedge it between, you drive on that with a hammer until this gets popped out, but that destroys the dust boot. Other tools will grab the component, will press on the end of the ball stud, and push that out. Now, I don't recommend driving on this at all. The ball stud should never be driven on with force or a hammer. The ball stud tool, the separator tool, is designed to put minimal force on the end of this in order to unseat the taper stud in the component. This should never be struck with a hammer. The back sides of these should never be hit with a hammer, whether or not they have a grease fitting. So striking the component with a shock or with a hammer or the dual hammer trick is going to send a shock throughout the component and help to release the ball stud that is seated in that taper. This is a good method to use, and you can reuse the parts. On vehicles that have crossover steering or solid axles, older trucks and vans, older cars, these are common to find on the tie rod ends for the adjuster sleeves. And you'll notice that the sleeve itself is split down the center, and then it also has these clamps that are also split with fasteners that tighten on the clamps. Inside the threaded adjuster are threads, and they are opposing from one side to the other. So one will have right-hand threads, the other side will have left-hand threads. And this is done so the inner tie rod and the outer tie rod end meet, and they're attached to whatever components on either side. And to shorten or lengthen the distance between their connection points, this adjuster sleeve can be rotated. One way will bring them closer together, rotating them the other way will spread them further apart. These are living down by the wheels and the axle, catching all the road grime, splash, de-icer, salt if it's used on the roads. All of those things can get lodged up inside and start corroding the threads inside of the adjuster sleeve. These will often be caked with grease and mud and dirt. Cleaning these out makes servicing the assembly much easier. When an adjustment is going to be made, these hex nuts need to be loosened to release the clamping force around the adjuster sleeve. Once the clamping force has been reduced, the adjuster sleeve can spin freely. Using penetrating oil like ZEP 45 or WD-40, some penetrating lubricant to get into the threads and help break some of that bonding that's been happening from this component being rigid and tight for a long time. When the adjustment has been completed, it's important to know where your clamp is on the adjuster sleeve. These clamps are not as effective if they are directly in line with the split in the adjuster sleeve, like that, or if they are completely opposite from the adjuster sleeve. It's also not as beneficial to have it set at 90 degrees because the clamping force is not putting an adequate clamping force on the adjuster sleeve. So ideally, when these are being set, go to the 10 o'clock or 2 o'clock position from the split. So either there or there. Somewhere in that area. So in between the 3 and 9 o'clock positions, you want to position that probably at the 10 or 2 position, which is ideal. Now when these are being rotated, you cannot determine where this split is going to land through the adjustment. Now these may need to be moved and repositioned into a different spot to accommodate for other steering linkage components that are moving close by, or to gain access to the fasteners so you can actually tighten them up, whether that's with a wrench or a socket. Always try to keep them within that 10 o'clock and 2 o'clock range of the split on the adjuster sleeve. One of the more common areas of wear on a rack and pinion steering system, or on any steering system for that matter, are the tie rod ends. So the tie rod ends, like we covered earlier, can be an inner tie rod and an outer tie rod like this, or they could have an inner tie rod separate from the outer tie rod joined with an adjuster sleeve. The way that most rack and pinions are set up is the inner tie rod end spins on its pivot point and has threads on one end. It may or may not have a hex profile to help adjust with the wrench, and then it threads into the outer tie rod end body and is locked together with a jam nut. The jam nut locks the threads together by seating against the outer tie rod end, keeping the threaded attachment point nice and solid and loading the threads to where there's zero play across the threads. Now each ball stud end, so this end here that goes into the steering arm, this can develop wear. We talked about the pivoting function of it, and that's normal. Checking for play up and down and side to side or lateral play is going to be key when doing an inspection on the system, including the dry park test, where you're using the vehicle's leverage from the driver's input at the steering wheel to load the steering system with the weight of the vehicle on the tires. By doing this, it exposes any weak points by showing the areas that are moving versus the areas that don't move. And when I talk about moving, I'm talking about where they shouldn't be moving. The steering should be able to swing the tires left and right, but we just want to load it enough left and right to expose any weak spots. So I'm going to walk you through servicing of the inner tie rod end assembly. These inner tie rod ends can wear and cause in and out play. So if this was on a vehicle and we were checking the tire, if we grabbed the tire at 3 o'clock and 9 o'clock and we wiggled it left and right and we felt some play, that play could be inside the bellows boot where the inner tie rod end socket is. So this socket has threads and oftentimes has a way to lock, and this will pivot, so I can grab this socket and spin it and it still feels tight. But it allows movement of the tie rod end assembly up and down with the control arm and the suspension movement. So as this wears, the tire doesn't track straight all the time and will develop uneven wear on the surfaces. The tool that's going to be used to loosen and tighten the replacement of the inner tie rod end is one of these tools. It has a 1/2 inch square drive on the back of it, perfect for a 1/2 inch breaker bar or a 1/2 inch drive ratchet. It's hollow down the center, and on the end there's a pivoting collar that exposes and locks over a groove or a notch that's cut on either side. For the inner tie rod end, it will often have a hex or 2 reliefs cut into it, and then using the corresponding adapter to the correct size, find the one that engages on the inner tie rod end, and then we can assemble the tool to remove the tie rod end. This fits inside of the tool, and then we flip our collar over so it locks it into position. I'm going to walk through the service procedure on removing and installing the inner tie rod end on this Mercedes power steering rack. That tool doesn't fit over outer tie rod ends regardless of the shape of the outer tie rod end. So the first thing we need to do is unseat the jam nut and unthread the outer tie rod end so we can remove the jam nut, unclamp the bellows boot, slide the bellows boot off, and then gain access to the inner tie rod end so then we can remove it with the inner tie rod end tool. When servicing the outer tie rod end, the first thing that needs to happen is remove the jam nut. The jam nut is tightened against the body of the outer tie rod end, so we also need to hold the outer tie rod end from turning. We can place a wrench along the outside of the body of the outer tie rod end, and then another wrench on the jam nut. Now this technique works pretty well when you're not working with a supported component, or just in general when you're breaking a jam nut loose, is to hold both wrenches together and position them to where you can squeeze them with both hands, and each of their energy is going to be transferred into the other and make the process of loosening the jam nut a lot easier. So I'm just going to squeeze these, and the jam nut is loose, and now we can unthread the outer tie rod end. What I'm going to do is count the number of turns it takes to remove the outer tie rod end. That way, if I'm installing a new part, or replacing the inner tie rod end, or replacing both of them, the new piece threads on the same number of times as the old piece when I removed it. And that's going to be more specific to the adjustment on the alignment of the vehicle. It's not going to get us exactly where we were before, but it'll be close enough to where it can drive around the parking lot, get onto the alignment hoist without the tire being drastically out of adjustment. So as we unthread it, I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, about 17 and a half is what I'm going to write on here. It's not super legible, but it's there, and I know that when I go back together and I thread this back on, I'll go on 17 and a half times and tighten the jam nut. I'll be at least close at that point. This one has an L cast into it. So without seeing anything else, I would venture to guess that this means that this is for the left side. So important things to pay attention to when you're disassembling components that are going to be reassembled. Take the jam nut off. Okay, next is the bellows boot. The bellows boot does not contain any sealing purposes. It's the job of the bellows boot is to keep dirt, water, contaminants, and other debris out from the portion of the rack that moves out into this portion of the bellows boot and the inner tie rod end pivot point. Those parts need to be protected and remain clean with the grease that they have inside of them. If there is fluid coming out of the bellows boot, or if you're getting fluid coming out of any of these points, that most likely means that the steering rack is leaking out of the end of the housing, which is non-serviceable, and the rack would need to be replaced and replaced with a rebuilt or a new unit. I'm going to remove the spring clamp that's holding this to the inner tie rod end. Just pinch it with some pliers. Comes right off. There will also be a clamp along the inner portion of the bellows boot, anchoring it to the body of the steering rack. That would need to be removed before the bellows boot can be removed from the rack. In this case, it's not there, so we'll remove it. And here we can see our inner tie rod end. This one is in really good condition. It's really tight. It supports its own weight very easily. Even if this was kind of floppy and loose, as long as there isn't play, it doesn't need to be replaced. With the bellows boot removed, you can see the entire inner tie rod end. This hex profile here is where the tool engages the inner tie rod end to lock and thread it onto the end of the rack. You can see some gear teeth on the rack itself, and our pinion gear is very close by. Okay, so here's our hex shape on the inner tie rod end for adjusting our alignment, our toe, and there's some grease in that ball socket right there. So this allows the suspension to travel while maintaining steering ability at the rack and pinion. So let's find the correct adapter for this and use the tool to remove it, and then reinstall and go back together for reassembly. So once we find the correct size, and confirm that that's going to work with the tool, then we can use the tool and slide it into place. We can't put this into the tool yet because the tool has to clear over the joint of the inner tie rod end first. So the best way to do this, and keep in mind this is usually going to be in the vehicle with other suspension and steering components in the area, so it's not likely to be very accessible. Using this tool makes it very, very convenient because you're working within the plane of the tie rod's movement. So by doing so, you don't have to access it from other angles. So I put this on here in a way that if I let go of it, it's not going to fall off. Then I'm going to slide the tool on and line up the tabs with the notches and then flip the locking collar over there. So now we're engaged and we can't take the tool off. Now using my super ultra mega handy 1/2-inch ratchet, long handled snap-on ratchet. These things are used all the time. They're like a breaker bar but a ratchet, and they're a lifetime warranty. So if you break it, you get a warranty. Highly recommend. We'll engage that onto the tool. Make sure we're set to off. There's our inner tie rod end assembly. So with the inner tie rod end removed, this would be either the same component being reinstalled, but more often than not, this is going to be replaced. On the portion where it threads in, there are no washers, locking tabs, or anything, just a nice flat flange that's going to mate against the end of the rack right here. Unless the manufacturer specifies something specific to use on the threads, this doesn't have anything else to help lock it in place, like a locking tab or a washer or something that folds over and mechanically locks it. So we're going to use more of the red thread locker, in this case Loctite. And we're just going to put a dab on the threads. Don't need a lot. And then we can thread that back on. This should have a torque spec. I'm not sure what that torque spec is, but I would guess for something like this, it would be somewhere around the 80 to 100 range. Put our tool back on so we can torque it to spec. Without a vehicle or a torque spec, I'm just gonna set this to 80 foot-pounds. £80 Release the collar, let it fall, lose it. Word of advice, when you hear something drop, that's a good sign. It means it hits the ground. If you hear it clank, 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 and you don't hear it hit the ground, then you gotta start looking around and peering up onto cross members and looking down into tight spaces. But when you drop something, whether it's a nut or a bolt or something, if you can, put your eyeballs on it. Watch it until it stops moving, because chances are that nut, that washer, that bolt is gonna roll around and land behind something like a toolbox wheel or something like that where you're not expecting to look. But saves a lot of time if you just stop what you're doing and see if you can find whatever just fell, if what you're doing allows to do that. Sometimes you're in a pinch, you're holding something heavy and you have to get the thing put on the ground or hoisted up into position. So if you drop something, find it right away is best case scenario. Otherwise you may lose it for good. And there's even a simple little piece, not just saying a type of a tool or a piece of a tool, but if it's a certain type of locking nut or something specific to the vehicle, getting a replacement may not be very easy. So try to pay attention anytime you drop something and find it right away. It's the best case scenario. It's going to take the least amount of time, and it just takes a moment to at least watch where it stops. That's key, knowing where it stands. If it's in the walkway, somebody can walk by and kick it. and then it sails across the shop to another service bay or somebody else's toolbox or some other bolts and nuts that may be on the ground. So just try to find whatever you drop. Good news if it lands and hits the floor. If you're hearing it do the plinko thing all the way down the vehicle and then it hits the floor, that's a good sign. So keep that in mind. Next, our bellows boot gets installed. Before we put the jam nut on, we'll put our locking clamp onto the boot. And before we thread the outer tie rod end back on, we need to put our jam nut on there. Now I forget how many times I spun this to remove it, so it's a good thing I have it written on the side there, 17.5. So I'll thread it to the point where it starts to catch the threads. Almost there-ish. And we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and a half. Before we set the jam nut, I'm going to show you how the toe is adjusted. We're going to get into alignments here this week, but I want to cover this real quick while I have this example available. The outer tie rod end, when it comes to adjusting for alignment, will be engaged to the component on the end of the outer tie rod end. So that's going to be the steering arm. With that attached there, we can't change the position of the tie rod end by pivoting the tie rod end itself. We have to spin the inner tie rod end, which is on the ball socket inside the bellows boot here. But if you remember, that ball socket allows for rotation of the inner tie rod end without compromising the effectiveness of the joint. So with the jam nut broken free, and I usually back it off a little bit, the inner tie rod end can then be rotated one way or the other, and those threads are moving into and out of the outer tie rod end body. And that's what's going to give us our adjustment. Now, the outer tie rod end is loose on the threads. So those threads have some play. And anytime that you cinch down a jam nut, it's going to take up whatever play is in those threads, depending on if you were bringing the threads into or pushing the threads out of. When you set the jam nut, it may change your readings more one way versus the other. And I hope to show you an example of that in the alignment video. So inner tie rod end is used to make the toe adjustment or center the steering wheel. And then we can lock our jam nut in place. And now our tie rod assembly is nice and tight with thread locking compound on the inside. Our outer tie rod end is rotated and installed to the same revolutions that it took to remove it. We set the jam nut. It's ready to go to alignment where the jam nut will be broken free. The adjustment will be done on the inner tie rod end right here with the hex. Hopefully it has a hex. Sometimes you just have to grab it with some channel locks or a pipe wrench or something like that in order to get the adjustment on the toe or centering the steering wheel. And that would be inner tie rod end service, ready to roll. I'm going to walk through the process of doing a dry park test on the CJ5, and it starts with having the engine off and the steering wheel unlocked, so we can turn this left and right and feel the resistance of the tires against the ground. And we're going to be moving the steering back and forth in between that little bit of free play. We're going to inspect the steering components for wear. As the steering is moved, we want to inspect any part where the steering linkage connects to another component. Here the steering column engages the intermediate shaft and goes down to the steering gearbox. Next we'll check the play coming out of the steering gear, into the pitman arm, and into the drag link. inspect the right front steering knuckle at the steering arm where the drag link connects and also connects to the right side of the tie rod. And finally, the left front tie rod end. And also pay attention to the movement of the axle in relation to the chassis, deflecting through the spring as the steering is loaded one way and then the other. When checking for play at the wheel in either the wheel bearings or the steering linkage or the suspension linkage, we have an upper ball joint, a lower ball joint, a spindle with serviceable wheel bearings on it. We have a tie rod end and steering linkage connecting to the rest of the chassis. To check for bearing play, you put pressure up top and down below. You should have a very, very little amount. You should have a little bit of wiggle in there to allow for expansion of those bearings. It's better to be on the loose side than it is to be on the tight side. This also checks your ball joints. Depending on whether or not your bearings are good, you may find ball joint play here or vice versa. The other method is the 9 o'clock and 3 o'clock position, doing the same test, checking for play in the steering and making sure that it doesn't move differently than the other tire. This is part of where the dry park test comes into play, where you can test this with the vehicle on the ground or on the drive-on hoist and have somebody move the steering wheel with the suspension loaded looking for play. Most of the time you'll need a partner to help you do the dry park test, with one person inside the vehicle constantly moving the steering wheel back and forth till it loads, and then moving across that free play till it loads on the other side. The technician that is doing the inspection can then go around to each component and look for items that are visibly loose or have play, and if you can't see it or you suspect it, another great way to tell if there's play in something is to hold it. So if I suspected this outer tie rod end had play and I couldn't see it, I would hold the outer tie rod end against the steering arm and squeeze it in my hand. And as that steering is moved left and right, I would be able to feel that play inside my hand. If I didn't feel anything moving in my hand, then that play is likely coming from somewhere else. But that is a helpful tool for trying to find items that are worn out and have play, is to use your sense of feel and feel that something's loose while it's being loaded and unloaded. Coming up this week is also going to be alignments. So we'll be reviewing a lot of the topics that we discussed related to the steering linkage, because it all comes into play when we're trying to align a vehicle. Until the next one, thank you.